Let's do this. All right, let's look at chemistry. You are welcome for today's tutorials. The subjects we have next is chemistry, and the topic is solubility. Solubility. Have you come across this topic in chemistry? Solubility. Is you? Have you? You've not done it in school, in your school. Eh? You've not. Chiwafa. Have you come across it? Eh? Underwater. So what about it? What is solubility? You must not define it the way you are to. Just give me an idea of what solubility is all about. I'm listening. What is solubility? No idea. Now, before you can understand solubility, what do you understand by solution? When you say something is a solution, what comes to your mind? In what? I know it's in liquid form. Is everything that in liquid form is a solution? So we'll keep the point. What is a solution? What is a solution made up of? What are the components of a solution? Dissolve metal. What is a solution? What are the components of a solution? Two what?
Different compounds. That are mixed.
Okay, now a solution is made up of solvents and what? Solutes. A solution is made up of what? Solvent and what? And what? Solutes. A solution is formed by dissolving a substance in another what? Substance. A solution is formed by dissolving a substance in another what? Substance. And that substance that is being dissolved is called a what? Solute. While the other substance that dissolves the solute is called what? Solvent. So what two of them form is what we call what? Solution. So that means there must be a dissolution. The solute must dissolve in what? Solvent for a solution to be formed. There must be dissolution. If the solute doesn't dissolve in the solvent, a solution will not be formed. Are we together? Are we together? Now, sometimes you may get a substance and try to dissolve it in another substance. That substance may not dissolve. It may form a suspension. Now let me give you an example. How you will know something? How will you know a liquid that is a solution? Is that after dissolving that solute inside the solvent, if you look at it, if you look at everything, it will that the solution, it will be clear. You will not see any cloud. It will be cloudy or turbid. It will be clear. You can even see through it. Now, I want us to look at these two practical examples. If you get sugar or salt and put in water, small amount of sugar and put in water or salt, what happens? It dissolves. Do you Would there be a change in the color of the water? The water will remain the way it is. I'm not saying that there are some solutes that are color. You will still see the color inside the solution. Water is all sugar. Sugar is not colored, right? So that's why if it dissolves in water, you can see it. But if you get something that is blue, after dissolving in water, you still see that blue. But it will be clear blue. You will not see cloud inside it. Let's say you are using something like a test tube. I can see through that test tube because the solute has dissolved. Now, but get something like powder. The powder you rub on your face, dusting powder, and put in water. What happens? And the whole water will turn to what? White, right? You can't even see anything. You can't even see it. Will be cloudy. That is not a what? A solution. In a solution, everything will dissolve. You will not see any particle of that salt inside that solution. That is how to know what is the word solution facially, as by looking at it. So a solution is composed of what? Solvent and what? So a solution is a liquid that contains a what? Dissolved particles called what? Solute. What is solute? Are the particles or substances that are dissolved in the what? In a solvent. So why a solvent is a substance that dissolves a what? A solute. Now this is just elementary explanation for you to understand what solution is all about. Now, with this basic understanding, let's consider one or two things in this word topic. Now, I want to point out something. We have what is called unsaturated what? Unsaturated what? Solution. We have saturated what? Solution. We also have super what? Saturated what? Solution. You know why I'm talking about solution? Because if you don't understand solution, you will never understand what? Solubility. So that's why I'm trying to explain what? Solution. Now, look at this now. What is an unsaturated solution? When you get a solvent now, something like water, and add small amount of salt. Have you ever tried it? Get a cup containing water, add small amount of what? Salt. It will dissolve, right? The more you add, the more it dissolves, right? That solution is unsaturated because it can take up more solutes. I'm not complicating. So an unsaturated solution is a solution that can still take up more what? Solutes. That is what unsaturated solution. So as you are adding the solute, salt, example salt, the more you add it, the more it dissolves. If you keep dissolving, keep taking in more solute, know that it is what? An unsaturated what? Solution. Now, what is a saturated solution? Now let me explain something. As you are not, even though salt dissolves, get water, maybe half tumbler, Keep pouring salt. Keep pouring salt. It will keep dissolving. Are we listening? Keep pouring salt. It will be dissolving. The more you pour, the more you dissolve. It will get to a point. The salt you are packing will be more than the water. And you can't even see the water again. The water cannot take more of the salt again. You start seeing the salt on the surface. True of us. Have you ever tried before? Try it today. The more you just get some more water, it will dissolve. The more you put, if you put, it dissolves. Put, it dissolves. That is an unsaturated solution. But if it will get to a point, the solution will be what? Saturated, that it can't take in any other what? Solute. And the undissolved one will be on the surface. When you get to that level where you start seeing the one that is not dissolved on the surface, that solution is what? And a saturated what? Solution. That solution is what? A saturated what? Solution. That solution is what? A saturated solution. All right, so this is what is called what? A saturated what? Solution. So this example I gave now is that of a what? Saturated what? Solution. Are we together? Any question? Any question? So with this explanation, let me define a saturated solution. But I've already this explanation I gave, there's something I missed. This whole thing, issue of a solution dissolving in a particular solvent, taking up the amount you can take, or in excess, all these things that have to do with solubility must be at a particular what? Temperature. It must be at a what? Particular what? Temperature. Because as temperature changes, solubility of a substance what? Changes. Have you noticed that? Have you tried to dissolve something? Not dissolve, you warm it, you heat it, it dissolves. Yeah? So as temperature increases, solubility does what? Increases. Now we'll still come to that, but let me just explain. Let me just define what a saturated what? Solution. Now, what is a saturated solution? A saturated solution is a solution of a solute. Are we together? Are we together?
Yes.
Sorry, let me start afresh. A saturated solution. A saturated solution is a solution that contains as much solute it can dissolve at a particular temperature in the presence of undissolved solute particles. A saturated solution is a solution. A saturated solution is a solution which contains as much solute as it can what? Dissolve at a particular what? Temperature in the presence of what? Undissolved solute what? Particles. I think I explained this, right? So, but the only thing you need to add there is what? Temperature. It should be at a particular what? Temperature. So whenever you are describing solubility of anything, whether it's something dissolved or not, think of the what? Temperature at which it was what? Dissolved. Because as temperature changes, a lot changes with respect to what? Dissolution. Now let's continue. Now, do you know why temperature affect this the dissolution? When this solution is saturated, there is a kind of equilibrium between the what? There's an equilibrium between what the SX. How do I explain this? Try to take this ball. Just try cleaning it. Now, you know, a saturated solution has two types of solute present there. Are you aware? A saturated solution has two types of solutes there present. The dissolved one and the what? Undissolved one. True of course. Now, what I'm trying to make is that there is an equilibrium between the dissolved one and what? I'm trying to describe the effect of temperature in the what? Saturated what? Solution. Now, we have the undissolved one and a what? Dissolved one. And for it to remain saturated, there's an equilibrium between the dissolved and the what? Undissolved solute. As in, they have reached this particular equilibrium. That's a balance. Two of them, it cannot take in anything again. It can't dissolve anything again. Both the one that is undissolved and dissolved will be at what? Equilibrium. Now, because of this equilibrium between the dissolved and the what? Undissolved, nothing can happen again. But if there is an increase in temperature, something will happen. Are you aware that there's what is called heat of solution? Are you aware that in dissolution, heat is absorbed? Am I forgetting? Heat is what? Absorbed. Now, because of this heat absorbed, even when the temperature, when you heat it, the same way you heat it, you are supplying heat into it. That heat that would what? That heat absorbed will alter this balance between the what? The saturated and the what? Unsaturated. And if there is imbalance between the saturated and the what? Unsaturated, it gives room for the solution to do what? Absorb what? To take in more what? Solutes. That's why the increase in temperature will lead to what? Increase in what? Solubility, or increase in what? Increase in the ability of the solvent of the solute of the solution to take in more what? Solutes. Is it clear? What I explain now, is it clear? Are you sure it's clear? Good. Now, this is what happened. This is what happened in what? Solubility in what? Saturated and what? Unsaturated solution. Now, what of supersaturated solution? What is it all about? Remember, in saturated solution, there is presence of undissolved what? Solute. But before I move over to supersaturated, there's something I want to point out. Just as you heat the saturated solution, it takes more solutes. That means increase in solubility. If you cool it down, as you cool a saturated solution, see what will happen. As you cool a saturated solution, the solutes will do what? Crystallize what? Out. That is, they become insoluble. True or false? When something crystallizes out from a solution, that means it become what? Insoluble. So as you cool the thing, they become what? Insoluble. So they will start crystallizing out, and as they get crystallized out, they are becoming what? Insoluble. So this is what happens when you increase the temperature or decrease the what? Temperature. When you increase temperature or do what? Decrease the what? Temperature. What crystallizes out? Is it the solute in the solution that crystallizes out, or the excess solute? Yes. Good. Now let's continue. What is a supersaturated solution? What is a supersaturated solution? I want to define something now. supersaturated solution. What is a supersaturated solution? You can put it down. A supersaturated solution is a solution that contains more of the solute that it can normally hold at a particular temperature. A supersaturated solution is a solution that contains more of the solute that it can normally hold at that temperature, or at a particular temperature. With these two definitions, like someone point out the difference between saturated and supersaturated solution. Can someone point out with these two definitions like I gave now? I want someone that can look at it again and tell us what you think is different between saturated solution and unsaturated solution. I said that a supersaturated solution is a solution that contains more of the solutes than it can normally hold. That is more than what it can hold. It contains more than what it can. A supersaturated solution is a solution that contains more solute. So it contains solute that is more than the one it can hold at that particular temperature. Remember what I told you, that the temperature affects solubility, right? Before you talk about solubility, you must define solubility with respect to a particular temperature. Now, at a particular temperature, there is amount of solute that particular solution is expected to do hold. But a supersaturated solution holds more than what it can hold at that temperature. So this is can someone point out the difference between a striking difference between supersaturated solution and saturated solution?
Saturated solution.
Okay.
Gets to a point, the solutes will be at the surface of the solvent.
Solutes.
Yes.
Undissolved
solute
Uh-huh.
will be at the surface of the solvent.
Okay.
But in supersaturated solution, it contains more
inside, right?
Yes.
So supersaturated contains more than what it can hold at a particular temperature. But a saturated will only get what it can hold. The excess one will just be on the surface as undissolved. So that means there is a presence of undissolved in saturated, but there is no presence of undissolved in supersaturated. This is striking the difference. Is it clear? You're just waiting for me to laugh before you say no. You don't want to think about it. Please go to your definition first before you say no. I gave you time to look at the definition and compare it to it. You do the comparison yourself. I gave you two definitions. Or did you not put them down? No. So go through the two definitions. I gave you time to do it. Go through the two definitions and tell me what you think. If you think what she said is not true, then go to your own definition and tell me what you think should be the difference. I'll give you two. I will explain the two of them already. So just tell me the difference between two of them. Because I explained. He said that he cannot make anything out of it. Explain what you just explained again now.
Saturated solution.
Mm-hmm.
They can take there's a point that the undissolved solute, and the solvent cannot contain it, so it will be at the surface of the solvent. But the supersaturated solution, it can contain more.
Mm-hmm. Supersaturated, please. Supersaturated is still saturated. I hope you know. Are you aware? Supersaturated is not unsaturated. It's still saturated, but it contains more than it can hold. Like now. Are you aware that there are people that can, or let me use some gallon now. Are you due to possibly because of the nature of what they use in manufacturing the gallon of the gallon. There's some type of gallon that you pump water. If you pump water inside it. Once it gets filled up, nothing else can enter. Are you aware? But there are some that can hold more than the capacity. Instead, they will just be becoming bigger, expanding. Are you aware? So, liken the supersaturated as to those ones that become bigger, expanding because they are forcing water. But there are some that cannot expand. In fact, instead of even expanding more, they may even do what? Burst. True of us? Good. Am I completing now? Now, because the supersaturated because the unsaturated ones cannot take more again, it will come out. It will be in the surface as what? Undissolved one. But in the supersaturated, they take in excess than they can hold, but they still hold it. They are saturated, but there's no excess. There's no undissolved one. They are just there. Am I communicating? Such is called what? Supersaturated. Now, if that is the case, we now look at what we throw more light on this supersaturated what? Solution. How would I bring this home now for a better what? Understanding. How do I bring this home for a better understanding? Okay, if you have you don't forget anything you are doing in solubility, put the temperature into what? Consideration, because it's vital. Now, if you, just as you have in a saturated solution, if you cool supersaturated, there will also be what? Crystallization. There will also be what? Crystallization, because the excess solid will do what? Crystallize out, even though there is no undissolved particles. There's no undissolved particles there, but the excess one inside that supersaturated this thing can do what? Crystallize out. There are some solid that you can see in such situation. You have sodium tetrahydrosulfate 6 decahydrates. Example is sodium tetraoxosulfate 6 hydrates. Sodium tetraoxosulfate 6 what? Hydrate. Even sodium triisothiosulfate what? 6 pentahydrates. See their formulas. This is the formula for sodium tetraoxosulfate what? Sodium tetraoxosulfate what? 6 pentahydrates. 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 6 what? Deca what? Hydrates. Decahydrate means 10 molecules of what?
Hydrogen.
Water of crystallization. Have you come across this? Hydrated salt. Have you? Good. So some salt like that is, example, sodium tetraoxosulfate 6 deca what? Hydrate. We also have sodium thiosulfate 6 pentahydrates. Sodium, sorry, there should be 2 here, sorry. Sodium, thiosulfate 6 deca what? Sorry, pentawatt hydrate. Sodium thiosulfate. This is thio. This is thio. Thio means sulfur. Thio came from what? Sulfur. Thio is from where? And anyway, you see thio in chemical name, it talks about what? Sulfur. Thio means what? Sulfur. So sodium thiosulfate what? 6 pentawatt hydrate. This is 3. This is sodium thiosulfate what? 6 pentawatt hydrate. Sodium thiosulfate 6 pentawatt hydrate. These examples, these 2 salts, they easily form what? Supersaturated what? Solution. They form what? Super what? Saturated what? Solution. Now let's continue. But there is something about this. There is something about this supersaturated solution. Let me ask you a question. Is saturated solution stable? Is it stable? Why do you say so? Is saturated solution stable?
Okay, because there's undissolved solvents.
We have already been told that the dissolved and undissolved particles are in what? Equilibrium. Right? So what does equilibrium means? Equilibrium means what? Balance. Means what? Stability. So it's stable. Is it clear? It's stable. Is stable, but this one is not stable. This supersaturated solution is not what? Stable. Supersaturated solution is not what? Stable. Any small thing will make the solute to do what? Crystallize what? Out. Just a scratch, a small scratch in the container. A small splash in the container that contains the what supersaturated solution. A small scratch from it will force the solution to do what? Crystallize what? Out. Even virtue of dropping a piece of that small piece of that solute in that supersaturated solution, this solute will do what? Precipitate what? Out. So it's not what? Stable. It's not what? Stable. Just even simple agitation, shaking the container it contains, that contains super what? Saturated solution. Just shaking that container alone, the solid can do what? Crystallize out because they feel what? The storm. Is it clear? They will do what? Crystallize what? Out. They can do what? Crystallize out. So, these are precautions one should take when dealing with what? Supersaturated what? Solution. Avoid particles entering it, no matter what it is. Now let's look at what is. You know why I explained, I took time, you know why I took time to talk about these solutions? Unsaturated, saturated and what? Supersaturated. Do you know why I took my time to explain them? Because now we want to enter into what? Solubility. We want to enter into what? Solubility. This thing I explain now is just preamble. It will help you to understand what solubility is what? All about. Now let's talk about solubility. Excuse me. I need water. Let's look at what? Solubility. I'll sit down and explain it. Okay.